warahmatullahi wabarakatuh. My name is Ahmed with my partner.
Ali Al-Murshid. We are a student in Qasim University College of Engineering.
Today we have an experiment. It's called Biot savart of a straight conductor, which is interesting experiment. The experiment has many goals. The first goal is determine the magnetic field of a straight conductor as a function of the current. The second goal is determine the magnetic field of a straight conductor as a function of the distance from the axis of the conductor.
Let's go to the show experiment. For materials, there is power supply, and there is Tesla meter, and there is P probe, and in the P probe there is whole
We will
sensor.
start the experiment. When I increase the current, the magnetic field will be increased. Let's go to enjoy the experiment. I will put the current 1 ampere. The magnetic field increased to 0.01. Now we record the information. And if I increase the current to 2 ampere, the magnetic field will be increased to 0.03. When I increase the current to 3 ampere, the magnetic field will be increased to 0.04 or 5 approximately. When I increase the current to 4 ampere, the magnetic field will be increased to 0.07 Tesla. Conductor. We have some of goals. The first one is determination of the magnetic field of a straight conductor as a function of the current. The second one is determination of the magnetic field of a straight conductor as a function of the distance from the axis of the conductor. And we have equation between magnetic field equal mu naught multiply current over 2 pi multiply R. If I want to study the relationship between magnetic field and current, we should make R is constant, and its value is 0.001 meter. And if we see the graph and we put B on the y-axis because it is alone, and I on the x-axis. We got in the lab physics, if the current is 1 ampere, the magnetic field should be 0.02, and if the current 2, the magnetic field should be 0.04, and if the current is 3, the magnetic field should be 0.06, and if the current is 4, the magnetic field should be 0.08, and this is the straight line. If I want to find the slope from this graph, we take 2 points. For example, and slope from this graph equal delta y over delta x. That's mean 0.6, 0.06 minus 0.04 over 3 minus 2. That's equal 0.02. This is the slope from this graph, and the value of the mu naught is always constant. But if we need to find it from this equation, mu naught equal 2 multiply by multiply r. R means distance from the axis of the conductor multiply slope. Now we reach at the end of video for this experiment. This is experiment or this is subject by supervising Professor and Dr. Jamal Din Ata. Thank you for listening.